Mr. Ryan, because this scare people off. Okay. So yesterday we talked about the subset. 1, 2, 3. Yeah. 1, 2, 3.
Yeah.
How many subsets of that?
8.
Yeah, 8. Because there are n numbers, n unique numbers. So we have total 2 to the power of n. Why is that? That's very easy to think of it. Yeah. For each number we have two choices. We pick this number in the subset, or we don't pick it. So there will be two choices,
right.
and there are n of it. So it's 2 times 2 times 2 here, 2 to the power 2 times that 2. There will be n 2's. So that's 2 to the power of n. Okay. So we use this backtracking. So for each one, define the fs. We have this current set C. And then we are looking at i's number. So if we reach the n is the numbers of the original unique numbers, and then we want to put all the subset into this list, answer list. And if I equals n, we reach the n, and we answer the we append a copy of the current set. So yeah, this symbol means a copy. So we can also do this copy here, right? And then we can. Otherwise, we have two choices, which is if we don't pick it, we move to the next number, or if we pick it, we include it in the current subset, which is nums I, yeah. And then we move to the next number, and then DFS start with empty list, the first number, return, answer. Yeah, easy. Okay. Okay, so today we're going to solve this problem slightly different. Okay, so by look, this is a very good thing is that we know the number of subset total is 2 to the power of n. Okay, so let's look at this number. Yeah, look 0 to 2 to the power, 3 numbers, so 0 to 7. So 0 in binary is, let's just look at 3 digits. Okay, because there are 3 numbers, 0, 0, 0. 1 is 0, 0, 1. 2 is 0, 1, 0. 3 is 0, 1, 1. Okay, can you tell me 4? What's 4? 5, 6, 7. Okay, so can you tell me the binary for this number? 4 is, I start first, 1, 0, 0. Okay, 5. What's 5?
1, 1, 0.
Huh?
0, 1.
1, 0, 1, yeah. And
You're
6?
so smart.
Yeah, 6.
1, 1, 0.
Where?
And 1, 1, 1.
Where down, okay. Yeah, you see? Always include. It's like this is the least significant bit, and this is the most significant bit. So look, from the right hand side we call it ASB. From the left hand side we call it MSB. Yeah, most significant bit. Okay. So each bit, this is 2 to the power of 0, 2 to the power of 1, 2 to the power of 2. Okay, so that's the most interesting part here. Okay. If it's 0, 0, 0, the subset is empty list. If it's 1, 1, 1, is 1, 2, 3. Okay? Okay, and then 0, 0, 1. 0, 0, 1, that is 1. Okay? 0, 1, 0 is 2. Okay? 0, 1, 1 is 1, 2. And then this is 3. This is 1, 3. Okay, so can you tell me 1, 1, 0? What's this? What does it correspond to? I give you the most. Look. 1, 1, 0. Anybody right? 1, 1, 0. What does it give us?
2, 3.
2, 3. Why?
I'm so smart.
Okay, so can you tell me why? Yeah, can you tell me why?
Because backwards is 1, 2, 3, and this is 1, and this is
Ah, well done. Good
this
spot.
is 1, 2. Yeah, because I'm smart.
Yeah, okay, so
Easy one.
there are 3 digits, so that's a good hint. 3 digits, original number 3, right? So if it is 0, we don't pick it. If it's 1, we pick it. Easy, right? So look at this. 1, 1, 0, 0. We pick the 3. We don't pick the 0 first, 1 and 2. So the result is easy. So we can just iterate over this number, and then by checking each bit. Okay? By checking each bit, we just need to check if each bit is set. If it's set, then we pick it in the subset. If not, then we skip it. Okay, and that will be it. Okay, I'm going to keep this, but I'm going to rewrite this bit. Okay, so this is called bit masking. Okay, masking. Bit. Yeah, bit. Each bit 0 or 1. Masking. What's mask? you put a mask, yeah, masking. So every time I look at one number and to one bit to see if it's 0 or 1, okay? So define the subset, these numbers. I'm going to write it, okay? It could be shorter, right? So the answer, and this n equals the length of numbers, yeah? We assume all the numbers in the subset are unique, okay? For I in range n, right? So we're going, no, not range n, range 2 to the power of n, right? 2 to the power n. We can say power to n or 1 shifty n position, okay? So, okay, so here is the thing, yeah? Power 2 to the power of n, this is 2 to the power of n. 1 shifty n, this is the same thing, is 2 to the power of n. Why is that? Look, 2 to the power of 3 is 8, yeah? This is power 2 to the power of 3. And then 1 shifty 3, what does it mean? Look, I have 1 here. I shifted one position to the left, I put a 0 in binary. I shifted another position to the left, I put another 0. I shifted another 1, okay. 3 0 at the end. What's this in binary? What's this in binary? Come on. Yeah, it's there.
8.
Exactly. Because this is 1, 2, 4, 8. Okay? So this is the same thing. Okay? So this is the same thing as power 2 to the power of n, or power, use the mass power 2n. Okay? This is the same thing. Now we go through this I. Now we need to go through these numbers. Yeah? So for j in range, we want to check each element to see if it's 1 or 0. So in range n. Right? So then we need to check if I, okay, so this is a binary, 0, 1. I want to check this number, so j, and, okay, this is binary n. 1 shifty j, then I put this current dot append nums j, okay? I'm going to tell you why, okay? The current equal at each round, the current is empty list, and if this bit is set, we include that number in the current set, and then answer for each round, we have a new subset, append current, okay? And then return answer, yeah, that will be return answer. Okay, so this is the most difficult part to understand. What's this mean? Okay, this I is this number, yeah? I is this number, this binary. So j, for example, the second one, the bit it represent is 1 shifty 1, which is 1 0 in binary, 0 1 0. The third bit is 0 1 0 0. Okay, so basically 1 shifted j is the index. So for the third number is 1 shifted j, which is 2, 0 1 2. Okay, 2. So this is 2 to the power of what? 2 to the power of how many? 2 to the power of 0, 2 to the power of 1, 2 to the power of 2. 2 to the power of 2 equals 4. So the bit masking for the third digit is 100, right? So if any of these numbers do the AND operation by this number, if it's more than 0, then we need to include this number. This is the same thing. What's N? Yeah, we talk about this N in if statement. Yeah, if Eric is a good boy and Ryan is a good boy, I give you both
Ultraviolet pens.
an apple, right? So something like
Yum.
N, yeah. Or if Eric is a good boy or Ryan is a good boy, I will give you both apple, right? So or is that at least one of it. N is that both needs to be true, right? So in binary it's the same thing. 1 and 1 is 1. 1 and 0 is what? 0 and 0. 0 and 1 is 0. 0 and 1 is 0. 1 and 0 is 0. 0 and 0 is 0. Okay, so this is the same thing as the if, right? So it will be 1 only if both sides are 1. If one of them is 1, it's not enough. Okay, so this is the same thing, okay? And then the n. Okay, so look at this time complexity. This is O to 2 to the power of n. And for each one, we need to iterate n times. So time complexity is O n times 2 to the power of n, okay? Right? Because look, this iterate, the inner loop iterates n times. The outer loop iterates 2 to the n times, right? 2 to the n times because there are n iterate subsets, okay? Yeah, okay, that's it for today. Good job. Bye bye. Bye bye.